A firm is evaluating two projects with initial investment and cash flows as follows. Spend a while to look at the table. Take note, project X is uneven cash flow and project Y is annuity, ordinary annuity. The firm's cost of capital is 5%. Complete the following table. Show your workings. Project X. Please take note, this is at the end of the year. It's very important to distinguish whether is it at the beginning or end. The cash inflow at 4 different timing, and all of them are not, the amounts are not the same. So this is an uneven cash flow. Let's draw a timeline. This is how the timeline looks like. And all these figures would be the future value at 4 different timing. We need to find PV. Let's do FV1 first. We want to find the PV for FV1. Here, the discounting period is 1 discounting period. So N is 1. So we put in this formula, substitute the figures in, refer to the PVIF table. Take note, this is PVIF table. This is a present value table, not future value. All right, please take note of this. Please make sure you get the correct table. Next, we'll go for, do I find the answer? We have given K and N. So that intersection is the answer. Substitute the interest factor into the working and find the present value. Now look at FV2. We're going to discount it to PV. So we are finding PV. There are 2 discounting periods. So N is 2. Using this formula, substitute the figures in, refer to the table. Make sure you get the right table. Next, we extract the answer. We are given K value and N. So the intersection is the answer. Substitute the interest factor into the working and find the present value. Moving on to FV3. Same thing, we are trying to find the PV for FV3. It has 3 discounting period here, so N is 3. So it's so we'll use the table formula here. Substitute the figures in. Okay, refer to PVIF table. Okay, please make sure you get the correct table. Next, we'll extract the answer. We are given K and N. The intersection is the answer. Substitute the interest factor into the working and find the present value. Moving on to add V4. Find the present value for add V4. It has 4 discounting period, so N is 4. So use the table formula, substitute the figures in, refer to PVIF table. Repeat again, PVIF table. Please make sure that you have the correct table. Next, we extract the answer. We are given K and N. So the intersection is the answer. Substitute the interest factor into the working and find the present value. Let's find the net present value. First, we consolidate all the PV together. So this is all the cash flow for 4 cash flow at 4 different timing. So find the grand total for present value of cash flows, inflows at 12,000 by then adding them all up. We less the initial investment and get the net present value of 2,000 plus. Project Y. Please take note, this is at the end of the year. Okay, I stress again, it's important to take note that this is at the end of the year. Take note the cash inflows the amounts are all the same. So this is an annuity. At the end of year, so this will be ordinary annuity. Let us draw a timeline. This is how a timeline looks like. Okay, with even cash flow throughout. So this ordinary annuity looks like. And we are to find PVA. Please refer to the timeline. Let's use formula. This is the formula. Substitute the figures in. Refer to the table. Please make sure that you have the correct table. It is very important that you get the correct table. This time around is PVIFA. Next, we extract the answer. We are given K and N. So the intersection is the answer. Substitute the interest factor into the working, and you will find the answer for PVA. We will define net present value for project Y and PVY. So this is the formula. Substitute the figures in, and you get the answer for NPV. Step 1. Find PVIFA IRR, N. Apply this formula to find the IRR. Substitute the figures in, work it out, refer to the table. We need to find the K, unknown K, and the interest factor, PVIFA. Make sure you have the correct table. Next, we will find the answer. We know N. We know the interest factor for IRR, 2.857. It's in between two figures here. We look at the one on the left. We have the interest factor and K. Now we have the value for K and the interest factor. Next, we look at the other one, the other interest factor. And also look for K. Now we have the value for K and PVIFA. Let us find IRR. We are going to use interpolation method to find IRR. The unknown is IRR minus 14% divided by 15% minus 14%. So you correspond the figures accordingly on the other side. And work it out. So the answer for IRR is approximately 15%. If the two projects are independent, what are your recommendations to the firm? If the two projects are independent, both projects are acceptable. Reason: both net present value are more than 0, or both IRR is more than the cost of capital. In short, the return is more than the cost. Any one reason would be sufficient because both IRR and net present value will give the same conclusion for independent projects. If the two projects are mutually exclusive, what are your recommendations to the firm? If the two projects are mutually exclusive, IRR and NPV will give different conclusions. Reason: IRR assumes intermediate cash flows are reinvested at IRR, whereas NPV assumes that intermediate cash flows are reinvested at the cost of capital. Therefore, NPV is the superior method because of its more realistic assumptions. According to NPV method, then we should select project Y.